Hello and warm greetings. My name is Rafał Podraza and I will be your instructor in this course. For over 6 years, I've been deeply involved in software testing. On a daily basis, I ensure the quality of delivered digital products, ranging from various software types. I also specialize in test automation and processes related to software compilation and deployment. Additionally, for almost 2 years, I have been an instructor on the Udemy platform, where I publish courses covering various testing branches, from topics related to manual testing to automation and API testing. Many of these courses have become bestsellers. Apart from courses, I have also authored the book Tester Certificate, which contains 400 questions and answers, helping individuals better prepare for the ISTQB exam at the foundational level. And in my spare time, if there is any left, I create educational materials on my YouTube channel.
Alright, let's start with something fundamental. What exactly is generative AI? You've probably heard this term 100 times in the past year, right? But what does it really mean? And why is it so different from traditional AI? In this lesson, we'll unpack that in a simple, practical way. So you'll understand not only what it is, but also how it works and why it's so powerful for QA. Let's start with a quick comparison. Traditional AI, that's the kind of AI we've known for years. It classifies emails as spam or not spam, predicts sales, or recognizes faces in photos. In short, it analyzes existing data and makes predictions. Generative AI, on the other hand, is a bit like a digital creator. It doesn't just look at data, it actually creates new data. It can generate a paragraph, an image, a line of code, or even a song that has never existed before. That's why the word generative. It literally means to generate something new. So, how does this magic actually work? At the core of generative AI, we have large language models, often called LLMs. These models are trained on huge amounts of text and books, articles, websites, and even code. And the way they work is surprisingly simple. They predict the next word in a sequence. For example, if I start a sentence with testing is an important part of, the model might predict software development. One word at a time, that's how it builds entire paragraphs or even full programs. It's not perfect reasoning, but it's incredibly good at finding patterns in context. The most exciting thing about generative AI is its versatility. You can use it to write documentation, explain complex topics, or even generate test cases. Developers use it to create code, testers use it to create test data, and designers use it to generate graphics. It's like having a creative assistant, one that doesn't get tired and can instantly generate ideas or solutions. Of course, it still needs your review, but it speeds things up dramatically. In quality assurance, generative AI can be a real game changer. Think about all those repetitive tasks. Writing test cases, preparing test data, documenting bugs. These things take hours, right? Now, with generative AI, you can offload a big part of that work. It can draft a first version of your test cases, generate data, summarize logs, and you simply review and refine it. That means you focus more on thinking, analyzing, and improving quality, not just typing. Of course, we need to be realistic. Generative AI is powerful, but it's not magic. It can make mistakes. Sometimes it invents facts or gives answers that sound right but aren't. That's what we call AI hallucination. So your job isn't to believe everything it says. Your job is to guide it, verify it, and use it wisely. It's a tool. And like any tool, it's only as good as the person using it. So, to wrap it up, generative AI is about creating new content, not just analyzing it. It's built on powerful language models trained on tons of data. For us in QA, it's a way to automate the boring stuff and focus on real quality. But remember, it's not a replacement for your brain. It's a partner that helps you think faster, not an autopilot that replaces you. And that's what makes it so exciting. So now that we know what generative AI is, let's go one level deeper. Let's talk about large language models, or simply LLMs. They're basically the engines behind tools like ChatGPT, Claude, Gemini, or Copilot. In this lesson, we'll look at what they are, how they work, and why they matter so much in the context of testing and automation. A large language model, or LLM, is an artificial intelligence model trained on an enormous amount of text. Think of all kinds of content: books, articles, websites, documentation, even source code. The model doesn't memorize this data. It learns the patterns in how we use language. It understands relationships between words, context, and tone. That's why when you ask ChatGPT a question, it can respond in a natural, structured way, because it has learned how language works. So, how does it learn? The process is actually surprisingly simple in concept. An LLM is trained on billions of text fragments, and its task is always the same: predict the next word, or more precisely, the next token. Let's say the model sees the phrase quality assurance ensures that it might predict the next word as software or product, because those are statistically most likely to appear. The model repeats this process billions of times, and eventually it becomes incredibly good at understanding context and predicting coherent sentences. Now, let's touch on the architecture. But don't worry, we'll keep it simple. Modern LLMs like GPT-4 or Gemini are based on something called the transformer architecture. The magic behind transformers is their ability to pay attention to context. That means when the model generates a word, it doesn't just look at the last one. It considers the entire sentence or even the entire paragraph. That's what makes its output so coherent and context aware. Transformers also allow parallel processing, which means they can train and generate responses much faster than older models. One of the reasons we call them large is because of their size, measured in parameters. A parameter is like a small piece of learned knowledge, a connection in the model that adjusts during training. GPT-3 had around 175 billion parameters, while newer models go even beyond a trillion. More parameters generally mean better performance and understanding, but also higher training costs and slower inference. So, there's always a trade-off between size, speed, and efficiency. There are many large language models on the market today, and each has its own strengths. ChatGPT, based on GPT-4, is probably the most well-known. Claude 3 by Anthropic is known for its reasoning and context retention. Google's Gemini is deeply integrated with search and tools, and Meta's Llama and open-source models like Mistral are used by developers and researchers who want more control. The variety is growing fast, and in QA this opens up more options for automation, documentation, and test data generation. The capabilities of LLMs are incredible. They can write human-like text, summarize long documents, or even generate and refactor code. In QA, you can use them to analyze test results, interpret logs, or even generate test cases based on user stories. Essentially, they turn raw text into structured knowledge. And that's what makes them so valuable. They can bridge the gap between natural language and technical automation. But, and this is important, LLMs don't think or understand like we do. They're brilliant at predicting what looks correct, but they don't know why it's correct. They can also produce wrong answers that sound perfectly confident, and because they rely on training data, they might reflect biases or outdated information. That's why human oversight is key, especially in quality assurance, where accuracy really matters. So to sum up, LLMs are the core technology that makes generative AI possible. They're based on the transformer architecture, trained on massive datasets, and capable of generating surprisingly intelligent text and code. But they're not perfect. They still need your judgment, especially when it comes to validation and correctness. Once you understand how they think, or rather how they predict, you can use them much more effectively in your QA workflow. So we already know what generative AI is and how LLMs work. Now let's connect the dots. Why should we, as testers or QA engineers, actually care about all this? Well, generative AI is not just some buzzword. It's a tool that's already changing the way we test, document, and communicate in software projects. Let's see exactly how. Let's be honest, working in QA can be tough. We're under constant time pressure, juggling deadlines and priorities. We often deal with repetitive work, writing similar test cases again and again, reviewing endless logs, and keeping up with documentation that's never fully complete. And let's not forget test data. Either it's missing, outdated, or it just doesn't match real-world scenarios. That's exactly where generative AI starts to shine. Think of generative AI as a kind of assistant that supports you in your daily QA work. It can draft your test cases, you just describe what the feature does, and AI gives you a list of scenarios to verify. It can also generate realistic test data, or even clean up messy datasets. When you're stuck with a complex bug, it can help explain the possible cause, or summarize long log files into something actually readable. It doesn't replace you. It extends you. One of the most underrated areas where generative AI helps is communication. Let's say you wrote a bug report and want to make it clearer for developers. AI can rewrite it in a clean, structured way. Or imagine you're preparing a test summary for stakeholders. You can feed raw test results into ChatGPT and ask for a professional, easy-to-read summary. It's also great for translation. For example, if you work in an international team, you can instantly produce English, German, or Polish versions of your reports. That's huge for productivity. Another big area is analysis. Traditionally, testers spend hours trying to find patterns in logs or identifying why a certain test failed. AI can help spot these patterns. It can read through logs, summarize trends, or even suggest potential root causes based on the data you provide. For example, you could paste error logs into ChatGPT and ask, what's the most likely reason for these failures? It's not perfect, but it can save you a lot of time in the investigation phase. One really interesting thing about AI is that it can be creative. In a good way. As testers, we often focus on typical use cases, but AI can help us go beyond that. It might generate strange but valid input combinations or unexpected what-if scenarios that we wouldn't think of ourselves. That's great for finding edge cases, the kind that usually slip through traditional test design. Generative AI isn't just about automation, it's also a learning companion. Let's say you're using a new tool like Playwright or Postman and you're stuck. Instead of Googling for 20 minutes, you just ask ChatGPT. It can explain the syntax, show examples, or even debug your code step by step. And when you have new team members joining, you can use AI to generate onboarding materials or test guides. That's how AI turns into a kind of shared knowledge hub inside your QA workflow. In short, generative AI helps QA teams save time, keep consistency, and reach better coverage with less manual effort. It also improves collaboration because you can generate reports, summaries, and documentation that are clear for everyone, not just testers. And most importantly, it frees you from repetitive work so you can focus on thinking, not just clicking. So, why is generative AI relevant for QA? Because it helps us do our jobs better and faster. It automates the boring stuff, enhances analysis, boosts creativity, and improves how we communicate results. But at the same time, it doesn't replace the human factor. Your experience, your intuition, and your critical thinking are still what drive quality. AI just helps you get there faster, and that's the beauty of it. In this lesson, we'll start with the basics. I'll show you how to create your ChatGPT account and what the first login process looks like. It's just a quick walkthrough, so you know where to click, what to type, and how to navigate the interface, before we move on to using AI in real QA tasks later in the course. Let's start by opening a web browser. It can be Chrome, Edge, or whichever one you usually use. In the Google search bar, let's type ChatGPT. After a moment, you'll see the search results, and we'll click the first link that leads to the official website. Notice that the domain is chatgpt.com. This is the page where we'll create our account and log into the tool. Great. We've just been redirected to the official ChatGPT website. Now we need to create our account so we can start using the tool. To do that, let's click the Sign Up for Free button in the top right corner of the screen. That's where our ChatGPT journey begins. We've now been redirected to the registration page. Here we can create an account in several ways, using Google, Microsoft, Apple, a phone number, or just a standard email address. In my case, I'll use the email option. So let's type in our email address and click Continue to move on. In the next window, we enter our password. Let's type it in and then click Continue to move on. Now we'll receive a verification code sent to the email address we entered a moment ago. Let's open our inbox, find the message from OpenAI, and copy the code from that email. Then paste it into the verification field and click Continue to confirm our email address and move on. Finally, we need to enter our first name, last name, and date of birth. Let's fill in these details and then click Continue to confirm everything and finish the registration process. After this step, our account will be ready to use. As we can see, our account has been successfully created. Everything's working just fine. From now on, we can fully use ChatGPT. In a moment, we'll go over the most important features. I'll show you the interface, where to find your chat history, how to switch to GPT-4, and where the settings are. That way, you'll know what's where and what's most useful in everyday use. At the very bottom, let's click the upgrade button. This is where we can change our account plan. For example, upgrade from the free version to ChatGPT Plus, which gives access to GPT-4 and some extra features. On this screen, we can see the 3 available ChatGPT plans: Free, Plus, and Pro. Let's start with the free version. The free plan costs nothing, but it comes with a few limitations. Access to GPT-5 is restricted, file uploads and image generation are slower, and memory and research capabilities are limited. Still, it's a great way to start and get comfortable with the tool. The Plus plan, priced at €23 per month, unlocks the full power of GPT-5. Faster responses, advanced reasoning, expanded memory, and agent mode. It also gives you access to projects, custom GPTs, and Sora video generation. Then we have the Pro plan at €229 per month, which is mainly for professionals and teams using AI every day. It offers full access to all GPT-5 features, unlimited messages and uploads, and maximum memory capacity. In this course, we'll be using the free plan, since it's more than enough to learn and explore everything we need. After leaving the subscription screen, we're taken to the main ChatGPT interface. This is where we can start giving commands and chatting with the model. In the center of the screen, you'll see the text box. This is where we type our questions or tasks, and then hit enter or click the arrow icon to send the message. Below, ChatGPT sometimes suggests a few sample prompts, which can be helpful if you're just getting started. From this point on, we can fully use the chat and explore what it can do. On the left side of the screen, we can see a panel with our chat history. Every new conversation we start is automatically saved here. We can easily go back to previous chats, reopen them, or delete the ones we no longer need. It's a really handy feature that lets us quickly access all our past discussions and ideas. A bit higher, above the chat history, there's a tab called Projects. This is a newer feature in ChatGPT that lets us create separate workspaces. Small projects where we can organize our chats, files, and settings. It's really useful if you want to keep things structured. For example, one project for API testing, another for learning, and another for documentation work. Here, in the Try Something New section, ChatGPT gives us a few example ideas we can try out right away. These are just suggestions, like creating a quiz, building a daily routine, or doing a color analysis. It's a quick way to test how the model works, even if you don't have a specific question in mind yet. It's also good to know that we can hide the left sidebar to get more space on the screen. Just click the small icon with 3 horizontal lines. And by clicking on the ChatGPT label in the top left corner, we can switch between different chat versions. For example, between GPT-4 and GPT-5, if our plan allows it. By clicking on Settings and then Personalization, we can customize ChatGPT to better fit our needs. Here, we see a panel with several different sections. We have General, for basic interface and app settings. Notifications, to manage alerts and updates. Personalization, where we can adjust how ChatGPT responds, including tone and communication style. Connectors, used to integrate ChatGPT with other tools. Data controls, to manage privacy and data storage. Security, for additional account protection. Parental controls, useful if younger users are accessing ChatGPT. And finally, Account, where we find our plan details and subscription info. It's a good idea to check this section from time to time, as OpenAI often adds new customization and privacy options here. In this lesson, we're moving on to one of the most important topics, prompt engineering, or in other words, the art of asking the right questions. The way we phrase our prompts has a huge impact on the quality and accuracy. Here, I sent a very simple prompt: write test cases. As you can see, ChatGPT responded by asking for more details to create accurate test cases. It wanted to know what kind of tests we're looking for: unit, integration, manual, or automated. And also asked for the programming language or test framework like Python, JavaScript, or Selenium. This is a great example showing that when a prompt is too general, the model has to guess what we actually mean. That's why in the next steps, we'll look at how to write more specific prompts that lead to clear, useful results. Here, I sent a much more specific prompt. I asked ChatGPT to create 5 test cases for a login page with username and password fields. And as you can see, the result is much more structured and detailed. Each test case includes an ID, description, preconditions, test steps, and expected results. For example, the first one is successful login with valid credentials, which checks if the user can log in with correct credentials. This clearly shows how powerful a well-written prompt can be. The more context we provide, the better and more useful the output becomes. Here, I went one step further and wrote an even more detailed prompt. I asked ChatGPT to generate 5 positive and 5 negative test cases for a login form with username and password fields. I also specified that the results should be presented in a table with the columns ID, description, test data, and expected result. Notice how specific this prompt is. It clearly defines what I want and in what format. That's why the output will be structured, clean, and immediately ready to use. While ChatGPT is generating the test cases, I'm opening Excel. I want to show you that you can copy everything directly from the chat and paste it into a spreadsheet. This gives you a perfectly formatted table with test cases that you can easily edit, filter, or include in your documentation. It's a huge time saver. One simple copy-paste and you're ready to go. This time, I use what's called a role-based prompt, where I define the role that ChatGPT should take. I asked it to act as an experienced QA engineer and generate detailed test cases for a user registration form with the fields name, email, password, and confirm password. I also specified that it should include edge cases and validation scenarios, which are often the situations where real bugs occur. This approach makes the model think like a specialist, in this case a QA professional, and produce much more realistic practical test cases. It's a great example of how defining the role properly can instantly improve the quality of the output. Then I added another prompt to expand on the previous test cases. I wrote, add test cases for invalid email formats and very weak passwords. So I asked ChatGPT to include tests related to invalid email formats and very weak passwords. This is a great example of how we can build on previous outputs instead of starting over every time. We don't need to write one massive prompt. It's often better to refine it step by step. ChatGPT keeps the context of the conversation, so it understands we're still talking about the same registration form and just adds new relevant cases. Now I added another prompt to take this example one step further. I wrote, convert the previous test cases into Gherkin format, given, when, then. So I asked ChatGPT to convert the previous test cases into Gherkin-style scenarios. This format is commonly used in behavior-driven testing frameworks like Cucumber or Behave. Each test case becomes a clear, readable scenario, with the given describing the initial state, when describing the user action, and then showing the expected outcome. It's a great way to move from traditional test cases to something that can be directly reused in BDD automation. Now I've added an even more advanced prompt that combines several testing areas into a single request. I asked ChatGPT to create 20 test cases covering login, registration, search, and checkout. I also specified that they should include both positive and negative scenarios, all presented in one table with example test data for each case. This is a great example of a complex prompt that allows you to generate a complete set of test cases for an entire user flow in just one step. It's especially useful when you need input data for automation or when preparing structured examples for test documentation. We've seen how much the wording of a prompt affects the quality of the results, from vague, general requests to well-structured prompts that produce accurate and organized outputs. We also practice different techniques, building prompts step by step, defining the model's role, generating test case tables, and even converting them into Gherkin format. I hope this gave you a clear idea of how powerful ChatGPT can be when you know how to communicate with it precisely. So far, we've seen how generative AI can help us in testing. It can write test cases, generate data, or summarize logs. But now it's time to slow down a bit and look at the other side of the story. Because as powerful as AI is, it also comes with limitations, risks, and ethical questions we can't ignore. Let's break those down and talk about how to use AI responsibly in QA. One of the biggest limitations of generative AI is accuracy. Sometimes the model simply makes things up. You might ask it to explain a failed test, and it gives you a very confident, detailed explanation. That's completely wrong. This is what we call an AI hallucination. The model doesn't know the truth. It only predicts what sounds like the truth. That's why in QA, you can never skip validation. Treat AI output like a draft. Review it, verify it, and confirm before trusting it. Another important thing. AI doesn't really understand your project. It can process text, but it has no awareness of your backend, your data flow, or your business logic. So if you ask it, doesn't know. Why did this API fail? It can guess, but it can't think like a QA engineer who's seen the system fail 100 times before. That's why it's not a replacement for your experience. It's a support tool that helps you reason faster, not reason for you. This one's critical. Data privacy. When using AI tools like ChatGPT, you should never paste real customer data, production logs, or internal credentials. Even if a tool promises data protection, you can't fully control what happens once the data leaves your environment. The best practice is anonymize data before sharing, use fake or synthetic data for demos, and always check your company's security policy. Remember, one careless paste can become a serious data breach. Another issue is bias. AI learns from public data, and that data isn't always neutral. If the training data contains stereotypes, outdated info, or skewed examples, the model might reproduce them. In QA, this can lead to misleading assumptions, like generating unrealistic user data or biased test scenarios. That's why human review is so important. You decide what makes sense in your context. The I doesn't know your audience, your users, or your ethical standards. One subtle risk is over-reliance. When AI gives quick answers, it's easy to stop questioning them. You might start copying responses without thinking critically. And that's dangerous in testing, because QA is about thinking deeply, not accepting blindly. So always stay in control. Let AI do the heavy lifting, but you make the final call. From an ethical perspective, responsibility is key. If you use AI to write documentation, generate test cases, or explain code, you're still the author. That means you're responsible for verifying and standing behind the results. It's also good practice to be transparent, especially in reports or documentation, about what was generated with AI. The idea isn't to hide it, but to use it responsibly and ethically. Another ethical dimension is the human side. AI can automate many tasks, but not everything. It can't show empathy, make strategic decisions, or understand human behavior in context. That's where testers still have the upper hand. So instead of worrying about AI replacing jobs, focus on developing the skills AI can't mimic: creativity, reasoning, and collaboration. That's your long-term advantage. So, how do we stay safe? It's simple. Anonymize data, double-check AI-generated results, and be open about when and how you use it. Combine automation with human insight, not one instead of the other. When you do that, you get the best of both worlds: efficiency from AI and accuracy from experience. To sum up, generative AI is an amazing technology, but it's not flawless. It needs guidance, context, and responsibility. When used wisely, it becomes a huge advantage for QA engineers. But if we forget about privacy, ethics, or validation, it can create more problems than it solves. So keep AI as your partner, not your pilot, and you'll get the best out of it. In this lesson, we're moving on to something very practical. We'll learn how to turn requirements into test cases using ChatGPT. This is exactly the stage where a tester transforms a feature description into specific test steps. I'll show you how to feed text-based requirements into ChatGPT and ask it to generate clear, structured test cases from them. We'll also see how to refine your prompts to get different levels of detail, from general scenarios to detailed tests with input data and expected results. By the end of this lesson, you'll know how to create a complete set of test cases in just a few minutes, without writing them all manually. Let's start with a simple example requirement. Here we have a short document describing the login functionality. It says that the user should be able to log in using a valid email and password, and if the credentials are incorrect, an error message should appear. At first glance, it looks very straightforward, but even from such a short description, ChatGPT can generate a complete set of test cases. Let me show you exactly how to do that step by step. Now I've opened ChatGPT and pasted our requirement along with a clear instruction. I asked it to generate test cases in a table format based on that requirement, with the columns test case ID, test scenario, preconditions, test steps, and expected result. And as you can see, ChatGPT immediately created a nicely structured table with test cases for the login scenario. We have a positive case, logging in with valid credentials, and a negative one, where an error message is shown after entering an incorrect password. This is a perfect example of how you can turn a simple requirement into ready-to-use test cases in just a few seconds. Now I've added another prompt to extend our test coverage. I asked ChatGPT to generate both positive and negative test cases based on the same login requirement. I also included edge cases and security-related scenarios, such as potential SQL injection attempts. Finally, I specified that the output should be formatted as a markdown table, with the columns test case ID, description, type, positive, negative, steps, and expected result. This is a great example of how you can combine different testing areas: functional, validation, edge, and security testing, all within a single well-structured prompt. Next, I added another prompt to make our table even more detailed. I wrote, add preconditions and post conditions for each test case in the table. That means I asked ChatGPT to include what needs to be true before the test starts and what should be true after it's completed. In other words, each test case now gets a full context, from setup to outcome. This is extremely useful in real QA documentation because it helps testers understand dependencies and system states at a glance. And the best part is that we can achieve this level of detail with just one short, simple instruction. Now I've taken it one step further, this time using a user story, which is the most common format for requirements in agile teams. I entered the story. As a registered user, I want to be able to reset my password via email so that I can regain access if I forget it. Then I asked ChatGPT to generate detailed test cases based on this story, covering functional, negative, and boundary scenarios. This demonstrates that ChatGPT can handle not only formal requirements, but also natural language user stories. Just like the ones we work with in real projects. It's the same process, just starting from a different type of input. Finally, I added one more prompt to show you something really practical. I asked ChatGPT to translate the generated test cases into German and format them as a bullet point list. This is a great example of how you can instantly prepare documentation in multiple languages. For instance, when working in an international QA team or creating reports and training materials for different audiences. ChatGPT keeps the structure and meaning intact, so there's no need for manual translation or a reformatting. And that's it for this lesson. We've gone through the entire process of moving from requirements to ready-to-use test cases with ChatGPT. We started with a simple functional description, then added more depth step by step. Negative cases, security testing, preconditions and post-conditions. And finally translated everything into another language and reformatted it. This shows how ChatGPT can be much more than just a helper. It can be a real partner in test design, documentation, and even multilingual collaboration. In this lesson, we're going to compare two different approaches to test design: traditional and AI-assisted. On one hand, we have the classic process where a tester manually analyzes requirements, creates test cases, and builds documentation step by step. On the other hand, we now have tools like ChatGPT that can generate complete sets of test cases, boundary scenarios, and even test data in just a few seconds. We'll look at how these two methods differ, what their strengths and weaknesses are, and most importantly, how we can combine them to get the best of both worlds. Because AI isn't here to replace testers. It's here to make their work faster, more precise, and more efficient. Now we'll go through the entire process of designing test cases manually, the traditional way. I'm using a simple login form here, where the user enters a username and password and clicks the login button. Based on this screen, we'll identify and design several test cases, both positive and negative. First, we'll do it manually by analyzing the fields and possible system behaviors. And then we'll see how ChatGPT can generate the same test cases automatically within seconds. This will let us directly compare both approaches and see how much time AI can actually save in real QA work. Alright, now let's move on to the traditional approach and try to manually design a few test cases. I'm using a simple spreadsheet here. In my case, Google Sheets. But of course, you could do the same in Excel, Notion, TestRail, or even in a basic text file. Let's start by defining the basic columns. We have the ID, the test case name, the type, meaning whether it's a positive, negative, or boundary test, and the expected result, describing what should happen when the test is executed. The first test case I'll add is login with valid credentials, a classic positive test. The user enters a correct email and password, and the expected result is user is logged in. The second one is login with invalid password and login, which is a negative test. Here we want to verify that the system correctly rejects invalid credentials and shows an error message. So the expected result is error message displayed. And the third example, login with empty email, is another negative case, where the user tries to log in without providing an email address. The expected result is a validation error, for example, validation error shown. That's the traditional process of designing test cases, analyzing possible scenarios, documenting them manually, and then using them later for testing or automation. For just a few cases, it's simple enough, but when you're dealing with dozens or hundreds of requirements, it becomes repetitive and time-consuming. That's why, in the next step, we'll see how ChatGPT can generate the same set of test cases instantly, keeping the same logic and structure, but without writing everything by hand. Now let's do the exact same thing, but this time with ChatGPT. I entered a simple prompt with the login requirement, and as you can see, within a few seconds ChatGPT generated a complete table of test cases. It includes everything we need: the test ID description, type, and expected result. It's the same structure we created manually, but this time it was generated automatically. This clearly shows how different the process becomes when we use AI. Instead of writing each case step by step, one well-crafted prompt is enough for ChatGPT to produce a structured, ready-to-use table that can be copied straight into Excel or any test tool. Now we're taking it one step further. In this example, I asked ChatGPT not only to generate test cases, but also to apply traditional test design techniques, like boundary value analysis and decision tables. The prompt I entered was, generate initial test ideas for the following feature: password reset via email. Then apply boundary value analysis and decision table techniques to refine the results. So first I asked for basic test ideas, and then for a refinement using structured testing methods. This approach combines classical tester thinking with AI-driven analysis. It's a great way to not only generate tests faster, but also to understand how ChatGPT interprets and applies formal test design techniques in practice. And this really shows the power of combining traditional testing techniques with generative AI. Instead of spending hours designing and documenting test cases manually, we can use ChatGPT to speed up the process, while still keeping the same structure, logic, and professional test design approach. The real value here is that we remain in control of the quality and accuracy of our tests, while AI acts as a creative assistant, helping us reach better coverage faster, and sometimes even suggesting ideas we might not have thought of ourselves. In this lesson, we'll move on to something practical. I've prepared a few example requirements and we'll see how ChatGPT can use them to automatically generate test cases. We'll start with simple ones, then move to slightly more complex examples, so you can see how the model handles different levels of detail and business logic. Throughout this section, I'll show you step by step how to write good prompts, what kind of information should be included in your requirements, and how to review ChatGPT's output to make sure the generated test cases are realistic and usable in real testing scenarios. Let's start with the first example requirement. Here we have a user login functionality, something that exists in almost every application. The description includes a few important validation rules and the expected behavior. The email must be in a valid format, the password must contain at least 8 characters, and if the credentials are incorrect, the user should see an error message. There's also an additional rule. After 5 failed login attempts, the account should be locked for 15 minutes. That gives us several different testing angles: positive, negative, and boundary scenarios. Now I'll copy this requirement and paste it into ChatGPT. In the prompt, I'll ask it to generate detailed test cases in a table format, and I'll specify the columns: test case ID, test scenario, preconditions, steps, and expected result. This way, the output will already have a clean and professional layout ready to use in a real project. After just a few seconds, ChatGPT generates a complete table with multiple login scenarios, step-by-step actions, and expected outcomes. As you can see, everything looks correct. We have cases for valid credentials, invalid ones, empty fields, and even the account lockout behavior. So the model was able to fully understand the requirement and translate it into clear, consistent test cases. Now let's move on to the second requirement, which covers the user registration process. This one is a bit more complex, since it includes several input fields and additional validation rules. When registering, the user needs to provide their full name, email address, a password, and also accept the terms of service. For example, by ticking a checkbox. The password policy is clearly defined. It must be between 8 and 16 characters long and include at least one uppercase letter and one number. That means we can already plan both valid and invalid scenarios to test these conditions. The expected behavior also includes a few special cases. After a successful registration, the user should receive a verification email, and if that link expires, the system should display a message like "link expired. Request a new one." Now I'll copy this requirement and paste it into ChatGPT. In the prompt, I'll ask it to generate positive, negative, and boundary test cases in a table format, including columns for test case ID, description, type, steps, and expected result. As you'll see in a moment, ChatGPT can accurately interpret this requirement and generate a full set of test cases, covering both typical and edge scenarios like invalid passwords, unchecked terms, and expired verification links. Now let's move on to the third requirement, which is about password reset. This is one of the most common flows in web applications, so it's a great example to work with. Here, a registered user should be able to reset their password through an email link. The flow is straightforward. On the Forgot Password page, the user enters their email address. The system sends a reset link that's valid for 30 minutes, and then the user sets a new password that follows the same policy as during registration. There are also some error cases described. For example, if the email doesn't exist, the system should show "email not found." If the link has expired, the message "link expired. Request a new one" should appear. And if the user tries to reuse the same link, they should see "this link has already been used." So as you can see, this gives us a variety of scenarios, from a successful password reset to negative and edge cases. In this example, I've pasted a prompt asking ChatGPT to generate positive, negative, and boundary test cases, formatted as a table with columns for test case ID, description, type, preconditions, steps, and expected result. ChatGPT will now generate a full set of test cases, covering everything from valid flows to invalid email addresses, expired tokens, and reused links. That gives us complete test coverage for the password reset process. Now, let's move on to the fourth requirement. This one focuses on API testing. This time, instead of testing the user interface, we'll be testing the backend endpoint responsible for login, which is post/auth/login. The requirement clearly defines the request format. We send an email and a password in JSON. The API can respond with 3 possible status codes: 200 OK when the login is successful and an authorization token is returned, 401 unauthorized for invalid credentials, and 429 too many requests when the account is temporarily locked after too many failed attempts. This is a realistic and common case you'll encounter in most authentication systems. Here, I'm pasting a prompt asking ChatGPT to generate test cases for this endpoint. I've also added an instruction to include not only positive and negative cases, but also security-related ones, checking how the API behaves under unusual or malicious input data. In the prompt, I defined exactly what I want in the output: a table with test ID, test scenario, method, request data, expected response, and type, whether it's positive, negative, or security related. With this, ChatGPT will generate a complete set of test cases, covering both normal login flow and edge scenarios, such as SQL injection attempts or malformed request structures. This shows how we can move beyond simple UI testing and start using ChatGPT for back-end level and API testing, making it a powerful tool for QA engineers in real projects. Finally, we're moving to the fifth requirement. This one focuses on the password reset API. Here we have two endpoints. The first one, post/auth/request reset, is used to send the reset email, and the second one, post/auth/reset, allows the user to set a new password using a token. The requirement also includes some validation rules. The token must be valid and not expired, and the new password must follow the same security policy, between 8 and 16 characters, including at least one uppercase letter and one number. Based on this, I've prepared the prompt you can see on the screen. I asked ChatGPT to generate test cases for both endpoints, covering positive, negative, and security-related scenarios. I also defined the output format clearly. I want a table that contains the test ID, endpoint, method, input, expected output, and type, whether it's a positive, negative, or security test. With this approach, we'll get a full set of test cases covering the entire password reset process, from sending the reset email, to handling invalid or expired tokens, to rejecting weak passwords that don't meet the security requirements. At this stage, ChatGPT is already capable of generating complete, well-structured test cases for full API processes, from login and registration to password reset. Now we're moving on to the final requirement. Requirement 6. The goal here is to create feature files written in Gherkin format that can be imported directly into tools like X-Ray or Cucumber. In this example, we're looking at a user login scenario that includes a lockout rule after 5 failed login attempts, a very common test case in authentication systems. This requirement demonstrates how we can automate the generation of .feature files based on structured requirements. Next, we'll open X-Ray and take a closer look at what it is and how it works. X-Ray is a popular test management extension for Jira. It allows QA teams to create, organize, and track manual and automated tests directly within Jira. The key advantage is that it supports importing test scenarios written in Gherkin, so all the test cases we generate with ChatGPT can be seamlessly uploaded into X-Ray and linked to specific requirements or user stories. In other words, ChatGPT helps us not only design better tests, but also automate their integration with professional QA management tools like X-Ray. Now I'm pasting the prompt that converts our requirement into Gherkin format, which can be imported directly into X-Ray or Cucumber. In this case, I asked ChatGPT to create 3 scenarios, one for a successful login, one for an invalid password, and one showing the account lockout after 5 failed attempts. In the prompt, I've defined exactly how the output should look. Only the pure Gherkin text, with sections like feature, scenarios, and steps using given / when / then. What we'll see in a moment is an automatically generated .feature file, the same kind you can upload straight into X-Ray. This means we don't have to manually write BDD scenarios anymore. ChatGPT can generate them automatically, fully compatible with X-Ray and Cucumber standards. In this step, we're focusing on exporting test cases to X-Ray using the CSV format. This is really useful because X-Ray can import tests not only from Gherkin files, but also from simple CSV text files. Here's the prompt I used for that. It includes all the required columns for X-Ray, project key, test type, test summary, precondition, test step, data, expected result, and labels. In my example, the project key is QA, the test type is manual, and the requirement describes a login scenario with an account lockout after 5 failed attempts. What's great about this is that ChatGPT can directly generate properly formatted CSV data, which you can simply copy and import straight into X-Ray. No manual editing needed. So this step completes the automation chain, from requirements through test generation, all the way to export. In the next part, we'll switch over to X-Ray itself and see how this looks in action. And finally, we've reached the last requirement, Requirement 8. Exporting to X-Ray. This one is especially useful for X-Ray Cloud users because tests can be imported directly through the REST API. No need to open the UI at all. Here, I've prepared a prompt that generates 2 sample manual test cases in JSON format, one for a valid login and another for an invalid password. Each test includes all the required fields: project key, test type, summary, precondition, and steps with action, data, and expected result. This JSON output can then be uploaded directly to X-Ray Cloud using the API endpoint post/API/v2/import/test. It's a fully automated way to push tests straight into X-Ray, from requirements to ready-to-use test cases in just a few seconds. So with this step, we've connected everything together. ChatGPT now acts as a full-fledged assistant for test design and test management automation. In this lesson, we're going to talk about the difference between structured and unstructured data. This is a term you'll often hear when working with APIs, databases, or AI systems. But many people still struggle to clearly understand where one ends and the other begins. Structured data is data with a well-defined format. For example, a table in an SQL database where each column and row has a specific meaning. Unstructured data, on the other hand, is the complete opposite. It's all those things that don't fit into a strict schema, like emails, chat messages, text documents, or even audio recordings. In this lesson, I'll show you clear examples of both types and explain why understanding this difference is crucial in data analysis, automation, and software testing. Now let's see what structured data actually looks like in practice. In this example, I asked ChatGPT to generate 10 realistic customer records, just like something you'd find in a CRM system or a user database. Each record follows the same structure, with columns like ID, full name, email, country, and age. Each field has a clearly defined data type, for instance, a number, text, or email address. That's the essence of structured data. Everything is neatly organized in rows and columns, easy to read for humans, and even easier for a computer to process. This kind of data works perfectly for reporting, analytics, API testing, or SQL queries, because it's consistent and predictable. ChatGPT has just generated some sample customer data, and now I'm pasting it directly into Excel. As you can see, it instantly forms a clear and organized table with columns like ID, full name, email, country, and age. Each record sits on its own row. One line, one customer. This perfectly illustrates what structured data really means. Every value has a defined type and position, making it easy to sort, filter, create charts, or export to a database or analytics tool. It's clean, predictable, and machine-friendly. Exactly what we need when testing or analyzing data. Now let's take a look at unstructured data. Here I've got some example user feedback messages, basically real-world comments about the login feature. And as you can see, this is very different from the previous structured data. There's no table, no fixed format. Each message looks completely different. Some are short and positive, like "works great," while others describe problems like "the system froze after a few login attempts." That's what unstructured data is. Text, open-ended information that doesn't fit neatly into rows and columns, but still contains a lot of valuable insight. We usually analyze this kind of data using AI models, language processing, or sentiment analysis. So now, I'm switching to ChatGPT and running a prompt that generates exactly this type of feedback. And here's what ChatGPT returns. It generates a few sample feedback messages. Basically what real users might write about the login feature. Each one is different. The tone, the length, the sentiment. Some are positive, praising how fast Google login works. Others are negative, complaining about random logouts or delays, with two-factor codes. This is the perfect example of unstructured data. There are no columns, no schema. Each message is just free text. It's valuable but also harder to analyze because before we can use it, we have to extract meaning. For example, detect whether the message is positive or negative. And this is exactly the kind of data AI models like ChatGPT are trained to understand and work with. On this slide, we have a clear comparison between structured and unstructured data. Let's start on the left. Structured data is organized, tabular. It lives in databases like SQL, and we can easily search, sort, or analyze it. Typical examples are customers, orders, or invoices. Things that follow a predictable pattern. On the other hand, unstructured data has no fixed format. It's usually free text, like emails, reviews, chat logs, or support tickets. We can't just throw it into a spreadsheet, but it contains valuable meaning, emotions, and context. When it comes to AI generation, structured data is produced as tables, JSON, or CSV files, while unstructured data looks like text, paragraphs, or natural conversations. So in short, structured data helps us analyze numbers, while unstructured data helps us analyze meaning. And in QA or data analysis, we often work with both. In this lesson, we'll focus on something absolutely essential when testing applications, generating realistic test data. Because let's be honest, tests that only use fake values like user1 or test@test.com might pass easily, but they don't really reflect how users behave in real life. Once the system goes live, issues start showing up. Users type names with accents, mix date formats, or paste entire sentences into input fields. That's why having realistic test data is so important. It helps us discover edge cases earlier and make our tests more reliable. In a moment, I'll show you how we can easily generate such data using ChatGPT, so our test environments feel much closer to production reality. Now let's move on to practice and see how we can generate realistic test data in just a few seconds. I'm typing a prompt asking ChatGPT to create 20 user records in a tabular format. I specify the columns: ID, full name, email, country, city, phone number, and registration date. Then I add a few important details. Names and emails should look realistic, in a European style. And phone numbers should use different country formats. Finally, I ask to return the result as a markdown table, so it's nicely formatted and easy to copy straight into Excel. This is a great way to instantly create data that actually looks real. Not those boring user1 or test@test.com values we often use in simple tests. As you can see, ChatGPT now offers to generate the same data as a downloadable file. I can choose whether I want it as a CSV or an excel.xlsx file. That's super convenient, but because I can open it directly in Excel, Google Sheets, or import it into a testing system without copying anything manually. So I'll click on Download Excel file, and in a moment we'll take a look at how the generated data actually looks. Now we'll take it one step further and generate data that looks like real e-commerce orders. I'm typing a prompt asking ChatGPT to create 10 realistic online store orders. I specify the exact columns I want: order ID, customer name, product, quantity, unit price, total price, order date, and status. Then I add a few simple rules to make the data more realistic. Total price should automatically be calculated as quantity times unit price. The status field should include different values like pending, completed, or cancelled, and the product names and prices should look natural, just like in a real store. This is a great way to instantly create meaningful data for testing, APIs, dashboards, or integration workflows. Now let's take a look at unstructured data, data that doesn't fit neatly into a table. This can be things like user messages, product reviews, or comments inside an app. Here I'm typing a prompt asking ChatGPT to generate 10 realistic customer feedback messages about an online shopping experience. I specify that I want both positive and negative comments, and that each message should sound natural, with slightly different writing styles, as if written by real people. This kind of data is perfect for testing things like sentiment analysis, where we want to see if an app can detect tone or emotion in user feedback. As you can see, ChatGPT now asks whether I want to organize these messages into a structured table, essentially turning unstructured text into a clean dataset with columns like feedback, ID, customer name, rating, and message. So I simply type yes. And ChatGPT will automatically transform all those free-form comments into a clear, structured table ready for reports, dashboards, or deeper analysis. This perfectly shows how AI bridges the gap between unstructured and structured data, something that would normally take a lot of manual work to achieve. Now we're switching to a format that's very common in programming and API testing, JSON. I'm typing a prompt asking ChatGPT to generate a JSON array of 5 users. Each user should include basic information like ID, a name, email, and country, and also an orders array with fields like ordered, product, quantity, total price, and status. This gives us realistic, structured data that looks just like what testers deal with when working with REST-APIs in real-world scenarios. It's a great example of how ChatGPT can instantly generate consistent multi-layered datasets that are perfect for automation scripts or testing mock APIs. Now I open a new browser tab and type W3 Schools SQL into Google. I click the first result that leads to w3schools.com. It's one of the easiest and most convenient sites for learning SQL. You can not only read about query syntax, but also run the examples directly in your browser, which makes it perfect for quick learning and database testing practice. The page has loaded, so now I'm clicking the Try It Yourself button. This opens an interactive SQL editor, where we can test queries directly in the browser without installing any tools or setting up a database. On the left side, we can write our SQL commands, and on the right, we immediately see the result. It's a great way to quickly understand how select, insert, or update statements work, and to experiment safely without affecting any real data. From the menu on the right, I'm selecting the categories table. This is one of the sample datasets available in this demo database. As we can see, after running select star from category semicolon, we get a table with columns like category ID, category name, and description, and several rows with values such as beverages, condiments, and dairy products. These are structured records stored in an SQL database. In a moment, we'll ask ChatGPT to generate an SQL query that will insert a new record into this table, so we can see how the insert into statement works in practice. Now we are moving on to something more practical. I am typing a prompt that asks ChatGPT to generate 5 new records for the categories table. In the request, I describe the table structure. It has the columns category ID, category name, and description. I also mentioned that the category ID should be automatically assigned by the database, so it shouldn't be included in the insert into statements. ChatGPT will return 2 things. First, a markdown table preview with the new categories, and second, the SQL insert statements we can copy straight into the W3 Schools SQL editor and run. This is a really efficient way to generate realistic test data without manually typing everything in. In this lesson, we'll talk about something really important: how to handle personal and sensitive information when working with generative AI. Because as testers, we often deal with real user data. Names, emails, phone numbers, maybe even payment details. And when we start using AI tools like ChatGPT or Postman with AI features, we have to be extra careful not to expose that data unintentionally. Let's start with the basics. Personal data is any information that can identify a person, directly or indirectly. It's not just obvious things like names or emails. It can also be an IP address, a username, or even a combination of data that points to a specific user. For example, if I tell you a 35-year-old tester from Rockwell working at company X, that might already be enough to identify someone. Then we have sensitive data. That's a special category of personal information that requires much stronger protection. This includes health information, religion, political opinions, sexual orientation, or biometric data. Even a small leak of that kind of data can cause serious harm, both for users and for your company's reputation. That's why regulations like GDPR treat it with such high priority. If you work in Europe or handle data from EU citizens, you're covered by GDPR, the General Data Protection Regulation. It basically says, collect only what you need, protect it properly, and don't share it without consent. For us in QA, that means we shouldn't store or process personal data in our test environments unless it's absolutely necessary. And if we do, we need to secure it properly. GDPR violations can lead to massive fines. But even worse, they can destroy user trust. Here's where AI adds a new layer of risk. When we use tools like ChatGPT, Microsoft Copilot, or any cloud-based AI, we don't always control what happens to the data we enter. If you paste real customer data or production logs into ChatGPT, that data leaves your organization's secure environment. Even if the platform says it doesn't store inputs, you can never be 100% sure. So, never share confidential or production data with public AI tools. The best approach is prevention. Before using any dataset in testing, anonymize it. Replace real names with fake ones, mask emails, or use synthetic data generators. For example, instead of john.smith@gmail.com, use something like user123@example.com. Also, try to separate your test and production environments completely. And make sure only authorized people have access to real data. The great thing is, AI doesn't need real data to work properly. If you want to generate test cases or analyze logs, you can do it with dummy data. AI only needs structure, not actual personal details. So you can safely train or test your prompts using example users like test user 01 or Jane Doe, and the output will be just as good. One last point, always follow your company's data security policies. If your organization uses an internal version of ChatGPT or another AI tool with enterprise controls, use that instead of public models. And if you ever realize that you accidentally pasted real data into an external AI tool, don't hide it. Report it right away so your company can take action. Transparency matters more than pretending nothing happened. So to sum up, handling personal and sensitive data is one of the most important responsibilities we have as QA professionals. Always treat real user data with care. Don't copy it into AI tools. Anonymize whenever possible and follow company policies. AI is an amazing assistant, but it doesn't understand privacy laws. That's on us. Use it safely, and you'll protect both your users and your reputation. Now we're moving to a very important topic: handling personal and sensitive information. In testing, we often need realistic data, but we must remember never to use real user information. So I'm typing this prompt: generate 10 fictional customer profiles for testing purposes. And I specify that each profile should include name, email, city, and phone number, while ensuring all data is 100% fictional and GDPR compliant. No real names, companies, or addresses. This is the right way to create realistic yet safe test data that doesn't violate privacy or any legal regulations. It's a good practice every tester should follow. Always generate test data ethically and responsibly. And as you can see, ChatGPT generated a set of fictional customer profiles, perfect for testing systems, forms, or APIs. Each record includes a name, email, city, and phone number. And all the data is 100% fictional and GDPR compliant. Notice that the email addresses use domains like examplemail.com or mockmail.org. These are non-existent test domains, which means they're completely safe to use. You can freely use this kind of data in test environments without any risk of exposing real user information. That's the goal. Realistic, yet completely safe test data. Now we're moving one step further to data anonymization, which means removing any information that could identify a real person. I'm typing a prompt asking ChatGPT to generate 5 anonymized records for a healthcare app test. This time, there are no names or emails. The fields include only patient_ID in gender, age group, diagnosis code, and appointment date. This way, we still get realistic and structured data, but it's completely safe and non-identifiable. That's exactly what anonymization is about. Keeping the data useful for testing, but protecting the individual's identity. Before we start generating tests with AI, let's take a quick moment to explain what Cypress actually is. Cypress is one of the most popular tools for front-end test automation. It's mainly used for testing web applications, the ones we open in a browser. Unlike older frameworks like Selenium, Cypress runs directly in the browser, which makes the tests faster, more stable, and easier to debug. You can literally watch your tests run step by step, which is super helpful when troubleshooting issues. With Cypress, you can test UI interactions, API endpoints, and even complete end-to-end workflows, from login to checkout. It integrates perfectly with JavaScript and TypeScript, making it a great choice for modern web projects. In short, Cypress combines simplicity, power, and modern design. In this lesson, you'll see how we can use AI to build our first Cypress test from scratch. Now we're moving on to the practical part. We're going to create a brand new Cypress project from scratch. We'll use npm, which is the package manager for Node.js, to install Cypress and set up everything we need. So I'm entering a prompt that generates the exact terminal commands. First, we create a new folder called Cypress AI Demo, then initialize npm with npm init-y, install Cypress using npm install cypress save dev, and finally open it for the first time with npx cypress open. These simple steps set up the entire testing environment, from an empty folder to a fully working Cypress project. In a moment, we'll take a closer look at its interface and folder structure. Now we open the terminal and paste the first command. This command creates a new folder called Cypress AI Demo and immediately navigates into it. This way we're working inside a clean dedicated directory where we'll soon initialize our Cypress project. It's a good practice to keep each test project in a separate folder. That way, dependencies stay organized and nothing conflicts. Now we copy and paste the second command, npm init-y. This command initializes a new Node.js project in our folder and automatically creates a file called package.json. This file is really important. It stores all the key details about the project, like its name, version, author, and most importantly, the dependencies we'll install later. You can see that npm has generated a simple default structure which will be the base for installing Cypress next. Next, we paste the command npm install cypress-save dev. This is the step where Cypress actually gets installed in our project. The save dev flag means that it's a development dependency, so it's only used during development and testing, not in production. The installation might take a little while, since Cypress downloads quite a few packages in the background. Once it's done, we can see that everything installed successfully. No errors. No vulnerabilities. Now Cypress is fully ready to run. Finally, we run the command npx cypress open. This command launches the Cypress graphical interface for the very first time. After a few seconds, a new window pops up. This is the welcome screen showing what's new in the latest release. Just click, continue to move on. This screen only appears during the first launch. In a moment, we'll see the main dashboard where we can create, run, and preview our tests. On this screen, we choose E2E testing, which stands for end-to-end testing. This type of testing simulates real user interactions directly in the browser. Then we click Continue and select Start E2E testing in Chrome. Cypress will now open its test environment inside Google Chrome. In just a moment, we'll see the testing dashboard, where we can create, run, and visually inspect our tests in real time. This is where the hands-on part begins, writing and running our first real automated tests. Now let's open our project in a code editor. I'm using Visual Studio Code, but you can use any editor you prefer. Once we open the project folder, we can see that Cypress has automatically created a project structure. There's a Cypress folder, and inside it we have subfolders like fixtures and support. Next to it, there are files like cypress.config, package.json, and packagelog.json. These are standard configuration files for a Node.js project. At this point, our environment is fully set up. Next, we'll create our first automated test and run it directly in the browser. Now, we open demo.applitools.com. It's a sample application with a simple login form that we'll use to create our first Cypress test. The form has two fields, one for the username, one for the password, and a sign-in button that redirects us to the user dashboard after a successful login. I also opened the element inspector to check which identifiers these elements have, because we'll use them directly in our test script. The username field has the ID number username, the password field has number password, and the sign-in button has number login. These will be the key selectors for our first automated test, which we're going to generate with the help of AI in just a moment. Now let's switch back to ChatGPT, because this is where we'll ask it to generate our complete end-to-end Cypress test. I'm pasting a detailed prompt that describes exactly what we want to do. First, initialize a new Cypress project, and then write a login test for demo.applitools.com. The prompt clearly defines each action: visiting the page, entering a username and password, clicking the sign-in button, and finally verifying that the user is redirected to the dashboard and that the text ACME dashboard is visible. ChatGPT will return a ready-to-use Cypress test script saved as cypress/e2e/login.cy.js with short comments for each step, a perfect starting point for automated testing. And here's the result of our prompt. ChatGPT generated a complete end-to-end Cypress test that automates the login process for demo.applitools.com. We can see all the key steps. First visiting the page, then typing the username and password, clicking the sign-in button, and finally two assertions. One that checks if the URL includes app.html, and another that verifies that the text ACME dashboard is visible on the page. Now we'll simply copy this code and paste it into the login.ky.js file in our Cypress project. Before we copy the code from ChatGPT, let's prepare our project structure in Visual Studio Code. Inside the Cypress folder, we'll create a new subfolder named E2E. This is where all of our end-to-end tests will be stored. Then, inside that folder, we'll add a new file called login.cy.js. In just a moment, we'll paste the generated test code here and use it as our first Cypress test. Now I'm simply copying the entire generated code from ChatGPT and pasting it into the login.cy.js file we just created inside the E2E folder. This file will contain our very first end-to-end test in Cypress, an automated login test for demo.applitools.com. Once the file is saved, we'll be able to run it and watch Cypress execute exactly the same steps we described earlier in our prompt. Now we copy the command npx cypress open, paste it into the terminal, and run it. After a few seconds, the Cypress graphical interface will open. We select E2E testing, end-to-end tests, and then choose the Chrome browser. Cypress will start in testing mode, and we'll see a list of all available tests. Our login.cy.js file should already appear in the list, and in just a moment we'll run it to test the login process automatically. Now we click on our test login.ca.js and we can see Cypress executing each step we wrote in the code. It opens demo.applitools.com, enters the username and password, and clicks the sign in button. We can clearly see that the user gets logged in and redirected to the dashboard. However, the test did not fully pass. The final assertion failed because Cypress couldn't find the expected text ACME dashboard. In this lesson, we're moving on to another powerful end-to-end testing tool, Playwright. Just like Cypress, Playwright allows us to simulate real user interactions in the browser. We can open pages, fill out forms, click buttons, and verify content all automatically through code. What really sets Playwright apart is its cross-browser and cross-platform support. It runs smoothly in Chrome, Firefox, Safari, and Edge, and you can even run tests in all of them at once. It's fast, stable, and built with modern testing pipelines in mind, especially great for CI/CD and TypeScript projects. Another big advantage is that Playwright can record your actions and generate test code automatically. So you can perform a few clicks manually and Playwright will write the test for you. That makes it a great starting point for exploring how AI can assist us in test automation. Now we switch to ChatGPT and ask it to generate a step-by-step guide for initializing a new Playwright project. In the prompt, we specify that we want to create a folder, initialize npm, install Playwright with the test runner, and run the setup command. Notice how the prompt is very clear. We tell the AI exactly what we want and ask for only the commands and short comments, nothing else. This is a great example of how AI can produce precise technical instructions that we can copy straight into the terminal. As you can see, ChatGPT returned a complete set of commands that will initialize a brand new Playwright project from scratch. We've got the steps to create a folder, initialize npm, install Playwright with the test runner, and even download the browser binaries. Below, the AI also added short comments explaining what each command does. So we can literally copy and paste them into the terminal without looking up documentation. This is a perfect example of how AI speeds up our everyday testing workflow. Instead of spending time searching or typing everything manually, we get a ready-to-use setup guide in seconds. And we can move straight into action. Now I'm copying the first two commands from the prompt and pasting them into the terminal. The first one creates a new folder called playwright-ai-demo, and the second command moves us into that folder. So we now have an empty workspace where we'll initialize our Playwright testing project in the next step. It's exactly the same logic as before with Cypress. We start by setting up the folder structure before installing any dependencies. Now we run the next command, npm init-y. This command initializes a new node.js project in our folder and automatically creates the package.js file. That file acts as the project configuration. It stores information about dependencies, scripts, and basic metadata. The -y flag tells npm to skip all the questions and use the default settings. So it's a quick way to get everything ready for Playwright installation. Now we run the next command, npm i-d at playwright/test. This command installs Playwright together with its built-in test runner. The -d flag means it's being added as a development dependency, so it's only used during testing, not in production. After a few seconds, the installation finishes successfully, and we can see there are no errors or vulnerabilities. That means our environment is ready for the next step, initializing Playwright and downloading the browsers. Now we run the command, npx playwright at latest install. This command downloads and installs all the necessary components for running Playwright tests, specifically the Chromium, Firefox, and WebKit browsers. With these installed, Playwright can run automated tests across multiple browser engines, ensuring that your web application behaves consistently everywhere. In the terminal, we can see each browser being downloaded and set up. Once this process is finished, our testing environment will be fully ready with all browsers and dependencies in place. So we can move on to initializing the Playwright project next. Now we copy the next command from the list. npx playwright at latest init. I paste it into the terminal and hit enter. As you can see, we get an error message. Error. Unknown command init. That's totally fine. In the latest versions of Playwright, this command no longer exists. It used to initialize the project and create the default folder structure, but now that process has been simplified. All we need to do now is run npx playwright install and it will do exactly the same thing. Download the necessary browsers and generate basic configuration files and sample tests. Now I'm running the command npx playwright codeengine example.com. As you can see, the browser opens automatically and the example.com page starts loading. What we're looking at right now is Playwright Codeengine, a built-in tool that records every action we perform on the page and converts it into ready-to-use test code. So everything I click, type or scroll here will be automatically turned into Playwright test steps. This is a super handy way to generate your first test within minutes, no manual coding required. In a moment, I'll show you how it works in practice. Now we are moving to the same page you already know from the Cypress lesson, demo.applitools.com. Here we have a simple login form, and this time we'll create a test for it using Playwright's AI-powered test generator. We'll type a username in the username field, enter a password in the password field, and click the sign in button. Playwright will automatically detect these actions and generate the test code for us. Just to remind you, these elements use the following selectors: hash username, hash password, and hash login. You'll see in a moment how the tool writes the test almost entirely by itself. Now we switch to ChatGPT and give it the following prompt. The goal is to generate a complete Playwright test for the login form on demo.applitools.com. We specify all the steps. Visit the page, enter the username and password, click the sign in button, and finally verify that the text ACME dashboard is visible after login. The result should be a ready-to-run JavaScript test file named test/login.spec.js. This is a great example of how quickly you can create a working Playwright test using AI without writing a single line of code manually. Let's see what kind of output we get. And here's the result we got. ChatGPT has generated a complete Playwright test saved as tests/login.spec.js. As you can see, the code is very clear. It visits the page, fills in the username and password fields, clicks the sign in button, and finally verifies that the ACME dashboard text is visible. Each step includes a short comment, so it's easy to follow what's happening in the test. This really shows how powerful the combination of Playwright and AI can be. Within seconds, we have a fully working test ready to run. Now we open our project in a code editor. I'm using Visual Studio Code, but of course you can use any editor you like. When you open the project, you'll notice that this time, Playwright didn't automatically create the test structure. There's no test folder or configuration file yet, so we'll create it manually. In the left panel, let's create a new folder named tests, and inside that folder, add a new file called login.spec.js. This is where we'll paste the Playwright test that ChatGPT just generated for us. It's a nice way to understand how to set up a Playwright test project completely from scratch. Now we can paste the test code that ChatGPT just generated for us. Let's open the login.spec.js file and paste the entire code inside. As you can see, Playwright's syntax is very readable. Even at first glance, it's easy to tell what each line is doing. Now let's copy the command to run our test and paste it into the terminal. As you can see, the test runs, Playwright automatically launches the browser, performs the login steps, and then checks whether the ACME dashboard text appears on the page. And here's something interesting. The test failed because that specific text wasn't found. That's a great demonstration of how Playwright immediately reports when something doesn't match our expectations. For now, I'll simply comment out the last line that checks for that text and rerun the test to make sure everything else works fine. And that's it! Our Playwright test has successfully passed. As you can see, the process is quite similar to what we did earlier with Cypress, but Playwright gives us a modern and powerful way to write fast, reliable end-to-end tests. We started by setting up the project and installing the dependencies, then created a tests folder and a login.spec.js file, and pasted the test code generated by ChatGPT. After running the test in the terminal, we saw that all login steps were performed correctly. The only check that initially failed was verifying the ACME dashboard text, but once we commented that out, the test ran perfectly. Before we move on to generating the test with AI, let's take a moment to talk about Selenium. Selenium was one of the very first browser automation tools, and for many years, it was the industry standard. It allowed us to open web pages automatically, click buttons, fill out forms, and verify if our web applications behave correctly. Selenium works a bit differently from Cypress or Playwright. Instead of interacting directly with the browser, it uses something called a WebDriver, a middle layer that sends commands to the browser. This makes it extremely flexible because Selenium supports almost every browser and programming language, from Java and Python to JavaScript. However, because of that extra communication layer, Selenium tests tend to be slower and sometimes more fragile. Still, Selenium remains very popular, especially in enterprise environments and long-running projects. So in this lesson, we'll see how to generate a similar login test, but this time using Selenium. Now let's move over to AI and see how it can help us set up a Selenium testing environment quickly. I'm going to ask ChatGPT to generate all the necessary commands for creating a new Selenium project in Python, step by step. In this prompt, I'm asking it to first create a new folder called Selenium AI Demo, then create and activate a virtual environment, install Selenium, download the Chrome WebDriver automatically using WebDriver Manager, and finally, create a test file named test_login.py. All that in short, ready to use commands. This is super convenient. In just a few seconds, we'll have a complete Selenium setup without digging through documentation. And here's what ChatGPT generated. A complete step-by-step setup. First, it creates a new folder called Selenium-AI-Demo and moves into it. Then, it shows how to create and activate a virtual environment. And it even includes different commands depending on whether you're using macOS/Linux or Windows. Next, we've got the commands to install Selenium and WebDriver Manager, which automatically takes care of downloading the Chrome WebDriver for us. That means no more manual setup or version mismatches. It's all handled automatically. Everything is clean, clear, and ready to go. We can just copy these commands one by one into the terminal and have our Selenium environment ready for testing. Alright, so here we've got the exact same login page that we used earlier with Playwright. This makes it super easy to compare both tools since we're testing the same scenario. It's a really simple form. We've got a username field, a password field, and the sign in button. Pretty standard stuff, right? There are also a few social media icons at the bottom, but we can ignore those. We'll just focus on the login functionality itself. The main thing we care about are these three elements: the username field with the ID username, the password field with ID password, and the sign in button with ID login. Exactly the same ones we used in the Playwright test. Now we'll do the same flow again, but this time with Selenium, and you'll see how similar and how different it actually is. Alright, so now we're moving on to the next step. And here I'm pasting a prompt into ChatGPT that will generate a complete Selenium test for us. Again, we're using the same demo login page from Applitools. In the prompt, I've listed everything step by step so the AI knows exactly what to do. First, open the Chrome browser and navigate to demo.applitools.com. Then, enter a username into the field with the ID username, a password into the field with the ID password. Click the login button, and finally, verify that after logging in, the text ACME dashboard is visible on the page. I also told it to use WebDriver Manager, so we don't need to manually install Chrome driver, and I've asked for short comments in the code, so it's easier to read and understand. At the end, the AI should return a complete Python script named test_login.py, which will be a fully runnable Selenium test file. Alright, so, as you can see, ChatGPT has just generated a complete Selenium test written in Python. The code looks clean, it's well structured, and it even includes comments for every step, so you can easily follow what's happening. At the top, we've got all the necessary imports: selenium.webdriver, WebDriver Manager, and the service class, which takes care of starting Chrome driver automatically. That's really convenient. We don't need to download or configure anything manually. Next, the test sets up the Chrome browser instance and opens the login page at demo.applitools.com. Then it maximizes the browser window just to make sure everything is visible. After that, we have the familiar actions: entering a username into the username field, entering a password into the password field, and clicking the login button. Finally, there's an assertion that checks whether the text ACME dashboard appears on the page after logging in. If it does, the test passes. If not, we'll see an error message saying the login failed. At the bottom, ChatGPT even included the command to run the test: pytest-q. So all we need to do now is copy that command, paste it into the terminal, and run it. In just a few minutes, we've got a fully working Selenium test generated automatically by AI. Alright, in this lesson, we're moving on to Postman, one of the most popular tools for testing APIs. If you're working as a tester, a developer, or you just want to understand how different systems communicate with each other, Postman is an absolute must-have. In short, Postman allows us to send HTTP requests like GET, POST, PUT, or DELETE, and inspect the responses returned by the server. It's great not only for manual API testing, but also for automation. You can create collections of requests, add JavaScript-based tests, use environment variables, and even set up monitors for your APIs. In this lesson, we'll see how we can use AI to generate a ready-to-run API test that you can paste directly into Postman. You'll see how AI can help us instantly create validations for response status codes, execution times, or even specific JSON values. Alright, so I've just opened jsonplaceholder.typico.com. This is a free public test API that's perfect for learning and practicing API testing. It allows us to send all kinds of HTTP requests, GET, POST, PUT, or DELETE, and immediately see how the server responds. It's not a real database with real users. It's just a fake one, made specifically for testing purposes. And that's great, because we can freely experiment, send requests, create posts, delete data, and nothing will actually break. So this will be the API we'll be using for our AI-generated tests in Postman. Alright, so here I've opened a specific endpoint, jsonplaceholder.typico.com/posts/1. What we see here is the response from the API returning a single post with the ID of 1. This is a great example of how a GET request works. We're simply fetching data from the server. In this case, the post title, body, and the user ID, which represents the author. In a moment, we'll use ChatGPT to generate the same kind of request automatically, and then we'll paste it into Postman to run our first AI-generated API test. Alright, now we're switching to ChatGPT and typing in the prompt you can see on the screen. We're asking it to create a GET request for Postman that retrieves a single post from posts/1. We also tell it to explain what the request does, include the necessary headers, and generate some example test scripts that will check things like whether the status code is 200, and if the response contains the fields user, ID, and title. So basically, ChatGPT will give us a ready-to-use Postman request with validation. We'll just copy it, paste it into Postman, and run it. ChatGPT has returned the complete request for us. At the top, you can see the GET method and the URL we'll be using, JSON placeholder.typico.com/post/1. I'm copying this URL and pasting it into Postman. Make sure the request method is set to GET, since we're only fetching data, not changing anything. Once we hit send, Postman will return the same result we saw earlier in the browser, a single post in JSON format. ChatGPT not only generated the request for us, but also provided some really useful details. It shows that we should include the application/JSON header. This tells the server that we expect a JSON response. Below that, there's even an example response showing exactly what we should get when we run the request. In this case, an object with the fields user ID, title, and body. So we already know what the correct output should look like. Let's switch over to Postman and send the request. I've sent the request, and as you can see, it worked perfectly. Postman returned a 200 OK status, meaning everything went smoothly. Below, we have the response body in JSON format, the same object that ChatGPT showed us earlier. It contains 4 main fields: user ID, title, and body. So our GET request successfully fetched the data for a single post from the API. Next, we'll see how to add a simple automated test in Postman. ChatGPT also generated a ready-to-use automated test script, which we can simply copy and paste into the test tab in Postman. Take a look. This code first checks if the response status is 200, meaning the request was successful. Then it passes the response into JSON and verifies that the response contains the fields user ID, and title. And that's really powerful. Postman will now automatically validate the response every time we send the request. This is where API test automation truly begins. After passing the tests, I clicked send, and as you can see, the tests ran automatically. The results appear below. In the test results tab, one test passed successfully while the other failed. And that's because I intentionally changed the expected status code to 201 to show you that the test logic actually works and detects mismatches. So, whenever the API response doesn't match what we expect, Postman immediately flags it as failed. This clearly shows that ChatGPT can not only generate requests, but also build working editable automated tests. Now let's move on to the next example. This time we'll create a post request. Here I'm pasting a prompt where I ask ChatGPT to generate a request that creates a new post in the JSON placeholder service. Besides the request URL and method, I also ask it to define the body, a sample JSON object containing title, body, and user ID. Additionally, I'm asking ChatGPT to generate automated tests that verify whether the response status is 201 and that the response contains a newly generated ID field. This shows perfectly how ChatGPT can generate a complete, working request and even include validation tests, all in just a few seconds. We got the response from ChatGPT and everything is clearly explained here. The method is post and the URL is jasonplaceholder.typico.com/posts. This endpoint is used to create a new post. So unlike the previous GET request, this time we're sending data to the server. Now JSON placeholder won't actually save this data because it's a mock API, but it simulates a real server response and returns an object that includes a newly generated ID. So let's copy this URL, paste it into Postman, and make sure that the method is set to post. Now I'm copying the request body generated by ChatGPT and pasting it here in the body tab. I make sure the option raw is selected and the format is set to JSON. As you can see, we have a simple JSON object with 3 fields: title, the post's title, body, the content, and user_id, which identifies the author. These are the values that will be sent to the API in this post request. In a moment, we'll click send and check the response to see if the post was successfully created. I've just sent the request, and as you can see, everything worked perfectly. The server returned a 201 created status, which is exactly what we expect from a post request. The response includes our JSON object with the title, body, and user_id, plus an automatically generated field ID, 101. That means the post was successfully created, or to be precise, simulated by the JSON placeholder API. It doesn't actually save the data, but it gives us a realistic example of how a real API would respond when creating a new record. Now, I'm copying the test script generated by ChatGPT and pasting it here in the test tab in Postman. You can see that this code automatically verifies several things. First, it checks whether the response status code is 201, which confirms that a new resource was successfully created. Then it passes the response into JSON, so we can easily access individual fields. The second test checks if the response contains an ID field, meaning the server generated an identifier for the new post. And the third test is optional. It verifies that the data we sent, title, body, and user ID, matches the data returned in the response. This shows how easily we can use AI to generate complete Postman test scripts automatically, without writing them manually from scratch. Now I'm sending the next request. This time, it's a put request. The put method is used to update an existing resource, so in our case, we're modifying an already existing post. As you can see, ChatGPT once again generated the full setup, including the endpoint, the request body, and even the test scripts. In the body, we have a new title and body, and the request goes to jasonplaceholder.typico.com/posts/1. After sending it, we receive a correct response. The server returns the updated post, and we can see that the ID stays the same, which means the resource was modified, not recreated. This is a great example of how ChatGPT can speed up the creation and validation of different HTTP requests, saving us time while we focus on learning or testing. Now we're generating the next request, this time with the delete method. The purpose of this request is to remove a specific resource from the API, in our case, the post with the ID one. Once again, ChatGPT has done all the work for us. It provided the endpoint, method, and even example test scripts that check whether the server returns status code 200 and whether the response body is empty, which confirms the resource was successfully deleted. After sending the request in Postman, we received a correct response. Status 200 OK with an empty body, exactly what we expect from a proper delete operation. In this lesson, we'll see how artificial intelligence can help us with code refactoring. That is, improving the structure and readability of our code without changing its behavior. In many projects, the code works fine, but over time it becomes messy, repetitive, or hard to maintain. That's exactly where AI can make a big difference. ChatGPT can analyze your code, suggest simplifications, remove duplicates, rename variables for better clarity, and even rewrite complex logic into cleaner, more elegant solutions. In this lesson, I'll show you how to use ChatGPT for these kinds of tasks. For example, to clean up an existing test script or optimize a function written in JavaScript or Python. You'll see that instead of doing all the heavy lifting manually, you can treat AI as your developer assistant, one that not only understands your code, but also helps improve it. Now let's move over to my GitHub repository, which contains a sample project with an automated test that we're going to refactor using AI assistance. The repository is called Cypress Framework Template, and it includes a full Cypress project setup with configuration files, folders, and example tests. You'll find the link to this repository in the resources section of the lesson you're watching right now, so you can download it and follow along step by step. Here we have the page object folder. This is where all the classes live that represent individual pages of the application. Each class contains selectors and methods that describe how to interact with different page elements, like logging in, adding a product, or searching for something. This makes our tests cleaner and easier to maintain because all the page logic is stored in one place. And just below, we've got the integration folder, or E2E in newer versions of Cypress, which contains our end-to-end tests, the ones that simulate real user behavior in the app. Now we're opening the api.spec.js file. This is our automated test file that we're going to refactor using AI. It's located in the cypress/integration/api/folder, and it contains a few simple REST API tests, for example, validating response headers, status codes, and checking specific response values, like verifying the Pokemon name Pikachu. As you can see, the code works fine, but there are some repeating patterns. The same endpoint appears multiple times, and the overall structure could be cleaner. That's exactly what refactoring is for, improving the structure and readability of code without changing how it behaves. Next, I'll show you how we can use ChatGPT to simplify and organize this code for better maintainability. Now we're switching to ChatGPT and pasting our prompt, which will let us refactor our test code. In this message, I tell ChatGPT to act as a Cypress expert and focus on improving readability and maintainability of the test suite. I also define some clear rules. For example, keep the same behavior and assertions, remove duplication, use before each for repeated requests, add short, meaningful comments, and keep the code in a clean, professional Cypress style. Then, right below the prompt, I paste the full code from the api.spec.js file, so ChatGPT can understand the whole context and return a clean, refactored version of our test. ChatGPT has now returned the refactored version of our test, and as you can see, the code looks much cleaner already. The first thing you'll notice is the use of the before each hook. This block runs before each positive test, so we no longer have to repeat the same request multiple times. It's now executed once automatically before every test. Next, we can see constants like base URL, valid Pokemon ID, and invalid Pokemon ID. That's a great improvement. Instead of hard coding values throughout the file, they're defined just once at the top, making the code easier to maintain and update. ChatGPT also grouped our test cases into two logical contexts, positive and negative tests. That makes it clear which tests should pass and which ones intentionally handle invalid cases, like a missing or non-existent Pokemon. At the bottom, there's even a short explanation summarizing what was improved and why. The code is now cleaner, better organized, and follows professional Cypress practices. This is a perfect example of how AI can help not just with writing new tests, but also with refactoring and improving the quality of existing code. Now we're taking it one step further. In this new prompt, I'm asking ChatGPT to refactor our test again, but this time using a data-driven approach. That means instead of testing a single Pokemon, we'll create an array of Pokemon IDs, for example 1, 25, 150, and then loop through that array, performing the same validation for each one. In the prompt, I also specify a few clear requirements. Create an array of Pokemon IDs, loop through the array and validate each Pokemon. Keep all existing assertions like headers, status codes, and names, and add clear logging to show which Pokemon is currently being tested. This makes the test much more flexible and scalable. We can easily expand it with new data without repeating the same code. Awesome! Now ChatGPT went one step further and created a truly data-driven version of our Cypress tests. At the top, we can see an array called Pokemon List, where each object contains the Pokemon's ID and its expected name. Instead of writing separate tests for each Pokemon, we can simply loop through this array using for each and run the same validation logic for all of them. Each Pokemon gets its own describe block, and before every test, the before each hook sends a request to the API. There's also a CI log command that tells us exactly which Pokemon is being tested in the Cypress runner. A small detail that really helps with debugging. All the assertions remain the same. We still validate the status code, the headers, and whether the Pokemon's name appears correctly in the response. But the test itself is now completely dynamic and scalable. If we want to test more Pokemon, we just add them to the list and the rest happens automatically. At the end, there's also a negative test that checks a non-existent Pokemon ID to confirm that the API correctly returns a 404 response. So in just a few seconds, ChatGPT turned a static test into a clean, reusable, and professional-looking Cypress suite. Now we're taking it to the next level. In this prompt, I'm asking ChatGPT to refactor our code once again, but this time by extracting the repeated logic into a helper function. The idea is to move the request logic out of the test and into a reusable helper. For example, a function called getPokemonById. That way, instead of writing ci.request multiple times, we can just call our clean helper method. In the prompt, I set a few clear goals. Move request logic into a helper or custom command. Replace all repeated ci.request calls. Keep all test names and assertions exactly the same. And use good Cypress practices for aliasing and chaining. This is where you really see the power of AI-assisted refactoring. We're moving from a simple script to a well-structured, maintainable test suite that looks like something you'd find in a professional QA project. Awesome! This is our third and final refactoring stage, and it looks just like something you'd find in a real, professional test automation framework. ChatGPT extracted the request logic into a separate helper function called getPokemonById. Inside that function, we have the entire request setup, the method, the URL, and a fail-on-status code parameter that we can easily toggle between true and false, which makes it perfect for both positive and negative tests. Now every test is super clean and readable. Instead of repeating side request, we just call getPokemonById 25 or getPokemonById 1000 false. And everything else happens behind the scenes, including the dot as open parentheses Pokemon close parentheses aliasing. All our assertions stay exactly the same. We're still validating headers, status codes, and the Pokemon name. But the code now follows DRY and professional Cypress best practices. At the bottom, ChatGPT nicely summarizes the improvements: extracted helper function, preserved aliasing, added flexibility through parameters, identical behavior and test names, and a clean modern Cypress style. This is a perfect demonstration of how AI can help us move from a basic test to a scalable production level solution in just a few iterations. And finally, let's take our tests one step further. This is where we move from refactoring to professional polish. In this last prompt, I'm asking ChatGPT to make the tests more robust and report friendly. Here's what I requested. Add custom console logs before and after each request. Improve assertion messages so they're human readable, like expected Pikachu name to match. Include a response time check, for example under 1000 milliseconds. And add graceful error handling using fail on status code false where needed. Now our tests don't just pass or fail. They also communicate what's happening. If something breaks in the CI pipeline, we'll instantly see clear logs and messages explaining why. This is the final level of AI-assisted refactoring. We started with a simple test, then made it clean and data-driven, and now we've turned it into a robust production-grade test suite that's ready for real-world use. And that's our final version of the code. We started with a simple test and ended up with a fully refactored solution using the getPokemon_by_ID function, which now logs details, measures response time, and gracefully handles errors. Each AI-assisted refactoring step added real value, better structure first, then a data-driven approach, and finally improved reporting and stronger test reliability. It clearly shows how AI can help us not just generate code, but also learn best practices and build truly professional test frameworks. In this lesson, we're taking the next step. Now that our code is fully refactored, we'll use ChatGPT to generate documentation and explanations for it. This is one of the most practical uses of AI. It's not always about writing new tests. Sometimes we just need help describing what the code actually does, or creating clear and consistent technical documentation for our project. You'll see how easily ChatGPT can explain functions, add JSDOC style comments, and even generate a clean summary for a README file. It's a great way to automate documentation and make your test framework more professional. Now it's time to generate explanations and documentation using ChatGPT. Since our code is ready, we can ask AI to describe step by step what each test does and why it's there. This kind of prompt works perfectly when you want to add comments to your code, create technical documentation, or prepare simplified learning materials. It's a quick way to make your tests easier to understand, without writing it all manually. As you can see, ChatGPT is capable not only of analyzing code, but also of creating detailed, easy to understand explanations for each test. What we got here is essentially a ready-made piece of technical documentation. The AI breaks down every test, explains what it does, what's being validated, and why it matters. You can use this output in several practical ways. First, it's perfect for your README file to help others understand the structure of your tests. Second, it fits great into your project wiki or Confluence pages, keeping your documentation both human readable and up to date. And third, it's excellent for training and onboarding, especially when teaching new QA engineers how to interpret test cases and results. This really highlights how AI can go beyond just generating code. Now it can explain, document, and teach, making our work as testers and developers much easier, faster, and more consistent. We already have full explanations of our tests in text form. So now we'll take it a step further and ask ChatGPT to add detailed comments directly inside the code. This is very practical because it means that every single line of the test is clearly explained. We know exactly what it does, what it checks, and why it matters. It's a great way to document your code in a way that's easy to read, both for other developers and for beginners learning test automation. As you can see, ChatGPT can do more than just write or refactor tests. It can document them directly in the code, line by line. Each comment clearly explains what the code is doing, what is being validated, and why it matters. This is incredibly useful when you want to create a readable, teaching-friendly version of your code, or when your team needs to quickly understand the logic of your tests without having to read extra documentation. With this approach, you end up with code that's not only technically correct but also self-explanatory, which makes it perfect for both professional QA work and educational projects. Now we're going one step further and using ChatGPT to generate a README file for our test project. A README is something that every repository should have. It explains what the project does, how to install and run it, and what exactly is being tested. With just a simple prompt, I can create a clear and complete documentation file, including test descriptions, setup instructions, example commands, and details about the API being used. It's a great example of how you can use AI to instantly produce professional project documentation ready to publish on GitHub or share within your team. And that's a great example of how powerful AI can be when it comes to documentation. We no longer need to manually write README files or explain what our tests do. A single well-crafted prompt is enough for ChatGPT to create everything for us in a clear professional format. You can instantly use that file on GitHub, share it with your team, or include it in a course project. AI not only saves time, but also helps keep your documentation consistent and easy to understand. That's the whole idea. Less manual work, more automation, and better project organization. In this section, we'll focus on something every tester deals with: error messages. Sometimes they're clear, but often they make no sense at all. We'll see how to use ChatGPT to analyze and explain them, so you can quickly understand what went wrong and how to fix it. I'll show you how to copy error logs or console messages into AI and get a human-readable explanation within seconds. Not just what failed, but also why it happened and how you can solve it. This approach is especially powerful when working with automated tests, where errors can be long, confusing, and full of technical jargon. I've just opened the file with some example error messages that we'll be working with in this lesson. It includes different types of issues that can occur while testing, both in Cypress and Postman. Here are some typical examples. 04 not found. When the requested resource doesn't exist. Type error, which happens when the code tries to access a property that's undefined. Socket hangup, a common Postman error that appears when the server connection suddenly closes. And 401 unauthorized, meaning the request wasn't properly authenticated. We'll use these examples to see how ChatGPT can analyze them, explain what exactly happened, where the issue comes from, and how to fix it. You can also download this file from the resources section of the lesson and practice analyzing these errors on your own. Now I'm pasting the first error message into ChatGPT. Take a look at the prompt. I'm simply asking the AI to explain the message in plain English and suggest possible causes and fixes. In this case, we've got a Cypress error. CR.request failed with a response code 404 not found. That means Cypress tried to fetch data from a specific URL, but the API couldn't find the resource. It doesn't exist at that address. It's a great example to show how ChatGPT can turn a technical error into a clear explanation and even suggest what to check, like the ID, the endpoint, or a possible typo in the URL. As you can see, ChatGPT immediately explained this error in a very clear way. It pointed out that 404 not found simply means the resource. In this case, the Pokemon with ID 1000 doesn't exist in the API database. What's really nice is that ChatGPT didn't just explain the problem, it also suggested possible causes like a typo in the URL, a version change in the API, or an invalid ID, and then showed specific ways to fix it. For example, it recommends trying a valid ID like one, which is Bulbasaur, or updating the code to handle the 404 error gracefully. So instead of failing, the test actually verifies that the API correctly returns 404 for missing resources. This is a great demonstration of how AI can help not only with debugging, but also with learning better testing practices for real-world projects. Now I'm pasting the next error example. This time, It's type error. Cannot read properties of undefined. Reading body. This is a very common error you'll encounter when working with Cypress tests. It basically means that the code is trying to access a property, in this case, body, from an object that doesn't actually exist. In other words, Cypress expected to get a response from the API, but the response was undefined. So when the test tries to read response.body, it fails because there's nothing to read from. In a moment, we'll see how ChatGPT breaks this down step by step and explains what's happening behind the scenes, helping us understand and debug the issue. As you can see, ChatGPT breaks this error down step by step. It starts by explaining in plain English that the code tried to do something like SomeValue.body, but SomeValue itself was undefined, meaning the variable didn't exist at all. In JavaScript, you can't access a property from undefined, so it throws a type error and stops execution. Then ChatGPT shows what was happening behind the scenes. The JavaScript engine tried to evaluate the expression, found that the variable was empty, and, according to ECMA SCRIPT rules, raised an exception. This explanation is super helpful because it doesn't just describe the error, it also shows the logical sequence of how the problem occurred. That makes it much easier to understand why a test failed and where exactly the issue started. Now we're moving on to another common example, the socket hang-up error, which often shows up in Postman or Cypress. At first, it sounds mysterious because there's no clear HTTP status code like 404 or 500. Just a vague message saying socket hang-up. In this prompt, we'll ask ChatGPT to act as a QA mentor and explain the error in detail, what it actually means, what typically causes it, how to fix or prevent it, and how to detect similar issues in the future. You'll see that ChatGPT breaks it down very logically. It explains what happens behind the scenes during client-server communication when the connection suddenly drops. As you can see, ChatGPT gives a very complete explanation here. It starts by saying that socket hangup means the TCP connection between the client, in this case, Postman, and the server was unexpectedly closed before the response was fully transmitted. Then it lists multiple possible causes. Sometimes the server closes the connection too early, sometimes Postman times out, and other times a firewall, proxy, or large request size can be the issue. In the next part, ChatGPT also provides practical troubleshooting steps, for example, reproducing the issue with curl-v, increasing the timeout in Postman, or checking server logs for messages like connection reset by peer or upstream timed out. This is a great example of how ChatGPT can help not only explain the error, but also guide you to think like a QA engineer, understanding the root cause, preventing recurrence, and learning how to diagnose similar problems in the future. So we've just gone through different types of errors, from simple ones like 404 not found, to deeper network level issues like socket hangup. In the end, ChatGPT shows how to compare errors and identify whether the issue lies on the client side, like Postman, or on the server side, which provides the HTTP response. For example, 404 not found means the resource doesn't exist, so that's a server-side or data issue, while 401 unauthorized means the client didn't provide valid credentials, so that's a client-side issue. Understanding this difference helps you diagnose API problems faster. You're not just reading an error code anymore, you're thinking like a QA engineer who understands the entire system flow. In this lesson, we're going to focus on log file analysis, one of the most important skills for any QA engineer. Logs are like a window into what's really happening inside the system. They often hold the answers to why a test failed, why an API returned an error, or what exactly was going on the server at a given time. I've prepared 3 example log files that we'll analyze together step by step. we'll look at how to identify errors, warnings, and HTTP statuses, and how to connect different log entries to see the full picture of what happened. You can find these files in the lesson resources. Feel free to download them and follow along as we go through the examples. Now let's move on to the practical part of this lesson, analyzing real Cypress log files. As you can see, I've prepared a prompt that asks ChatGPT to analyze the logs. The goal here is to automatically detect all error and warning entries and summarize them in a clear, structured way. In the prompt, I specifically ask for what the error means, when it occurred, the possible root cause, and the suggested next steps to fix or prevent it in the future. This approach is super useful, especially when dealing with long Cypress reports that contain multiple repetitive error messages. Now I'll paste the Cypress log file into ChatGPT and we'll see how it goes through the content line by line, analyzing, grouping, and summarizing all key issues. The result will be a clear list of errors with explanations and actionable insights, something you can later include in your QA report or incident summary. You'll also find this log file in the lesson resources, so feel free to download it and follow along with Mia. Perfect. Here we have a complete report generated from our Cypress logs. Take a look at how clearly ChatGPT summarized everything. At the top, we can see the summary of detected issues, with one error entry showing exactly what failed in the test. It expected the API to return Pikachu, but got Pikachu instead, just a simple typo in the test data. The meaning column explains what happened in plain English, and the possible root cause points out the likely issue, a mismatch between the expected and actual API response. Below that, ChatGPT added additional test statistics, including total tests, duration, and even recorded artifacts like screenshots or videos. The root cause analysis section makes it clear that this wasn't a network or server issue, but a data validation problem. So the fix would simply be correcting the expected value in the test. This is a great example of how you can use ChatGPT to analyze test logs and instantly turn them into readable, actionable reports. You can even paste this summary directly into your test documentation or a Jira ticket. Now we're moving on to another practical example, and this time we'll analyze Jenkins logs. That's something every QA engineer encounters sooner or later, because CI/CD pipelines tend to fail quite often, whether it's during the build, deployment, or automated test execution. I'll use the same kind of prompt as before. The idea is simple. ChatGPT will analyze the Jenkins log, detect all error and warning messages, explain what they mean, when they occurred, what likely caused them, and finally, suggest what to do next. This saves a lot of time. Instead of scrolling through hundreds of log lines, we'll get a clean, structured summary that's easy to understand, even for people who are not familiar with Jenkins yet. In a moment, I'll paste a real Jenkins log, and ChatGPT will generate a full table summarizing all detected issues, the type, the timestamp, a short explanation of what happened, and the probable root cause, like a missing environment variable, a permission problem, or a network timeout. Now let's move on to the last part, analyzing server logs. This is a bit more advanced than the previous examples, because these logs usually show what's happening deep inside the application, on the back end, in the API layer, or even in the database. We'll use the same kind of prompt again. ChatGPT will look for all error and warning entries, explain what each one means, when it occurred, what the root cause might be, and suggest practical next steps to fix or prevent it. This time I'm pasting a sample server.log. These are the kinds of logs you often get when something goes wrong in production or staging. After running the analysis, ChatGPT will return a clean table showing the error type, timestamp, description, and possible cause. It may also include a root cause analysis section that helps us understand whether the issue is caused by a missing file, a database connection problem, a timeout, or something else. This makes it much easier to report bugs clearly. Instead of just saying the server returned 500, you can provide context. For example, the backend threw a null pointer exception in the user service. In this lesson, we're moving on to the final step, creating summaries and reports. This is where we take all the data, logs, and test results and turn them into something readable and actionable. A report that clearly shows what passed, what failed, and what needs attention. To start, I'll show you a sample test report, which you can also download in the resources section as a PDF. It's a simple example report, but it's perfect for understanding what a clean and minimal test summary should look like. As you can see, it includes basic details: the test name, how many tests passed or failed, the total duration, the specific error message, showing what was expected versus what was actually returned, and even a warning about a slow API response. This kind of report is the foundation for automation and AI-assisted analysis, because from here, we can let ChatGPT summarize it, generate quick notes for Jira, or even create full QA reports with recommendations. In this lesson, we'll take that simple report and learn how to transform it into a professional summary document that not only lists results, but also explains why things failed and how to fix them. Now let's move to the practical part of this lesson. I'll take the same report we just looked at, and this time I'll ask ChatGPT to generate a short, professional test summary based on it. In the prompt, I clearly define what I want in the output: the number of tests passed and failed, the main failing test name, a short root cause summary, and an overall result. For example, mostly successful or requires attention. This is a very effective way to automate reporting. You can use it not only for individual test files, but also for full Jenkins pipelines or nightly Cypress test runs. After a few seconds, ChatGPT will produce a clean and readable summary that you could easily paste into Jira, Slack, or a daily QA report. It's concise, it's well structured, and it looks exactly like something you'd expect from a professional test management tool. Here's the summary generated by ChatGPT. There were 5 tests in total, 4 passed and 1 failed. The failing test, validate user endpoint, expected a 200 status but got a 404 instead. ChatGPT points out the likely cause: invalid or missing test data for user ID 999, and marks the overall result as requires attention. A clean, quick report you can instantly share with your team. To wrap up this lesson, let's take one final step. I'll ask ChatGPT to generate a ready-to-use QA report table. All we need to do is specify the columns we want, like test case name, result, duration, error message, and suggested action. This gives us a clean, structured report that can be added to documentation or shared with the team. It's a perfect example of how AI can automate not just analysis, but also the reporting process itself. And here's the final QA report generated by ChatGPT. The table includes all key details: test name, result, duration, error message, and suggested action. We can see that only one test failed, the user validation test, while all the others passed successfully. This kind of report can be downloaded or added directly to documentation. A great example of how AI can turn raw test data into a clean, professional summary. So by now, you've probably realized that generative AI can do a lot. It can write code, generate test cases, create reports, and even analyze logs. But here's the thing, not everything it does is great. Some things work surprisingly well, others not so much. In this lesson, I want to share with you a realistic view from my own experience. What works well with AI in QA and what simply doesn't. Let's start with the good part. Generative AI works extremely well when it comes to automation support. If you ask ChatGPT to generate a Cypress or Postman test, it usually gives you a good starting point. It can also explain what each part of the script does or help fix an error message. It's not perfect, but it saves a ton of time, especially when you're dealing with repetitive tasks or you just need a quick example to move forward. AI is also really good at the creative part of QA, test design and documentation. For example, you can describe a feature and ask AI to suggest test cases, and you'll often get interesting ideas, including edge cases you might not have thought about. It can also help you expand user stories or acceptance criteria, or summarize large pieces of documentation into something short and clear. In short, AI is great for brainstorming and writing, but remember, it's your job to verify if those test ideas actually make sense in your project. Another area where AI really shines is analysis and explanation. You can give it a long JSON response, a stack trace, or a messy log file, and it will summarize the problem in seconds. It's great for quick diagnostics or when you're trying to explain technical details to non-technical people. It doesn't replace deep debugging, but it helps you get a clear first impression much faster. Now let's talk about what doesn't work so well. AI is not good at reasoning. It can't really understand the system like you do. It might explain why something failed, but often that explanation is just a guess. Also, if you give it a complex test automation framework or a huge piece of code, it can miss dependencies or oversimplify the issue. So while it's great for quick help, it's not yet ready to replace your technical analysis or debugging skills. Another issue is inconsistency. You can ask the exact same question twice and get two completely different answers. Sometimes one response is spot on and the next one makes no sense at all. This happens because LLMs are probabilistic. They don't memorize. They predict patterns. So you always need to give them clear, structured prompts and ideally double-check the answers before trusting them. Generative AI also struggles with domain-specific knowledge. If your company builds something niche, for example a financial API or a custom healthcare app, AI won't know all the details. Its training data may be outdated or too generic, so it can generate examples that look right but don't really fit your business logic. In those cases, it's better to guide the model step by step and feed it real context from your system, without exposing sensitive data, of course. The best approach is to combine your expertise with AI's speed. Let AI do the boring parts, generate drafts, test data, documentation, or quick code snippets. But use your experience to check if it actually makes sense. Think of AI as your co-pilot. It helps you fly faster, but you're still the one holding the controls. That's where the real value comes from. The combination of automation and human judgment. To sum up, generative AI works amazingly well for automation, writing, and summarizing tasks. It's fast, creative, and saves tons of time. But it still struggles with reasoning, consistency, and understanding complex systems. So the key is balance. You provide the expertise. AI provides the speed. Together, you can get better results than either one alone. Alright, so we've talked about what AI can do and where it helps us in QA. But we also need to be aware of the other side, the risks that come with using AI tools. Because if we start using AI carelessly, we can easily create new problems. Things like data leaks, wrong results, or even compliance violations. In this lesson, we'll look at the most common risks and what you can do to avoid them. The first and biggest risk is data privacy. Many testers use ChatGPT or other AI tools to analyze logs or write test cases. But sometimes without thinking, we paste real user data, API keys, or internal code into a public model. That's a problem, because you don't control what happens to that data once it leaves your company. Even if OpenAI or Microsoft says they don't use your data for training, policies can change. So, the rule is simple. Never use real or confidential data in public AI tools. Always anonymize it or use fake test data instead. Another big risk is inaccuracy. Sometimes AI just makes things up. We call that hallucination. You might ask for an API test example, and it gives you a perfect looking request, but with a wrong endpoint or invalid JSON. It looks good, it sounds smart, but it's wrong. So always double check the output before using it in your project. Use AI as a starting point, not as the final truth. Another limitation that can easily turn into a risk is lack of context. AI doesn't understand your internal setup. It doesn't see your database, architecture, or environment. So if you ask it to generate test cases, they might look correct in theory but not match your real system. That's why AI suggestions often need to be adapted to your project's reality. You bring the context, AI just brings the structure. Over-reliance is another subtle but dangerous risk. The more we use AI, the easier it becomes to stop questioning its answers. You might get used to copy-pasting results without critical thinking. And that's where mistakes happen. QA has always been about curiosity, asking why, and digging deeper. Don't lose that. AI is an assistant. It helps you think faster, but it should never replace your thinking. Here's another thing that most people forget. AI is only as good as its training data. Most models are trained on text from the internet, which means the data might be outdated or even biased. For example, an AI might recommend using an old testing framework or deprecated syntax because it doesn't know the latest updates. That's why your expertise matters. You know what's current. AI doesn't. There's also a growing ethical and legal risk. When AI generates text or code, it might reuse patterns from copyrighted material without you realizing it. So if you copy that code into your project, you might technically be violating someone's intellectual property. Always check company policies on using AI-generated content. And when in doubt, treat AI output as a draft you need to review and modify. A more technical risk comes from security. AI can generate code fast, but it doesn't automatically make it secure. For example, it might suggest hard-coded credentials, missing validation, or vulnerable API calls. So before you use AI-generated code in production or testing pipelines, always review it like you would code from a junior developer. It can save you from serious issues later. The good news is, all these risks are manageable. If you follow a few simple rules, you can use AI safely. Don't share anything confidential. Always validate the results manually. Keep a human in the loop. And stay aligned with your company's data and security policies. Use AI wisely, and it becomes a strength, not a threat. So to wrap it up, AI is incredibly powerful, but it's not risk-free. The main dangers come from data exposure, inaccuracy, over-reliance, and unclear legal ground. As QA engineers, our job is not just to use AI, but to use it safely and responsibly. When we combine automation with awareness, we make sure that AI works for us, not against us. In the last lessons, we've talked a lot about what AI can do, and also about its risks and limitations. Now it's time to look at something even more important: how to combine AI with human judgment. Because the truth is, AI is not meant to replace us. It's meant to work with us. When we combine AI's speed and creativity with our experience and critical thinking, that's when the real magic happens. Let's start with the obvious. Why humans still matter? AI is fast, but it doesn't have experience. It doesn't understand business priorities or human behavior. We, as testers and QA engineers, bring something AI can't replicate: context. We understand why something is important, who it affects, and what the risks are. We also bring ethics and empathy, two things no algorithm can simulate. That's what makes human judgment irreplaceable. On the other hand, let's be fair. AI has its own superpowers. It's incredibly fast. It can process thousands of lines of code or logs in seconds, and it never gets bored of repetitive tasks. It's great at recognizing patterns, spotting similarities, trends, or inconsistencies that we might miss after hours of manual work. So instead of competing with AI, we should let it handle what it's good at and focus on what we're good at. The real power comes from combining both. For example, AI can generate test cases, data, or even a full test script in seconds. But it's your responsibility to check if those test cases make sense, if the data matches the requirements, and if the script is stable. AI helps you move faster. You ensure it moves in the right direction. That's the perfect balance. AI handles the volume. Humans handle the value. Let me give you a quick example. Imagine you ask ChatGPT to generate 50 test cases for a login form. You'll get a big list instantly. Functional tests, negative cases, maybe even a few creative ones. But then you, as a human, come in and filter them. You remove duplicates, adjust priorities, add missing edge cases, and check if all business rules are covered. So instead of spending hours starting from scratch, you spend minutes improving something that's already there. That's the perfect use of human plus AI collaboration. But here's the trap, and I see it happen all the time. People start trusting AI too much. They stop checking results because it looked fine. That's a big mistake. AI can generate ideas, but it shouldn't make final decisions. Only you can define what quality means for your project. Use AI as your assistant, not your manager. Another great way to combine human and AI strengths is through teamwork. When you use AI in testing, don't do it in isolation. Share your prompts, results, and insights with the rest of your QA or dev team. Sometimes someone will spot an error or find a smarter way to ask a question. That's how you build real collaboration, not just between humans and AI, but also within the team. Working with AI is not just about tools, it's about mindset. The best testers who use AI effectively are curious, skeptical, and always learning. They experiment with prompts, compare results, and don't accept the first answer blindly. They treat AI like a colleague, sometimes helpful, sometimes wrong, but always worth listening to. That's the mindset that will keep you relevant in the future of QA.